can see the slides from there. I think I might have ruined a joke too by showing slides. But this is my first slide. This is my family here. I've been married to my wife 11 years. This is kind of everything that's important to me in the slide and what I do. So you can find me on the web, vancelucas.com, @vlucas. I'm a Christian and a realist from Oklahoma City, so hail from an hour and a half away. I work at Oracle. I worked at NetSuite. Oracle bought NetSuite fourth quarter last year, so I'm at Oracle now. A principal software engineer there and a JavaScript team lead for the product that we're building. And I've been 100% JavaScript there for the whole time I've been there, so 2.5, 3 years. And it's my work there. Does this sound scratchy on the feed? There's like, it sounds kind of scratchy to me. Am I too close? There we go. Maybe I'm too close. And my work there has kind of led to this talk. Some performance things I had to investigate and debug while I was there. I co-founded the Thunder Plains conference and Techlahoma. And if you heard the announcements at the beginning, we have our call for papers open. So it's thunderplainsconf.com if you want to check it out, if you want to submit something. We're also going to have a beginner's track or a kind of a lightning talks or open spaces. So we do have opportunities for new speakers in a smaller room as well, if you would like to submit. I just ruined a joke, man. I was going to say, this is my family. I have 3 kids, and I also have a brand new 10-month-old, and then I was going to say Ford Mustang, and it was going to be like a haha joke, but I ruined it. Sorry. You can laugh at me instead. So the goal of this talk really is to say that your browser is your IDE. So if you're a JavaScript dev, you don't really need an IDE, and you probably don't use an IDE. Maybe you do. There's some new ones that are good. VS Code and stuff might count as one, and some other things. But your browser can serve as your IDE for the purposes of debugging, profiling, getting some introspection on your code, and everything that you need to do that is already built in your browser. So there's nothing you have to download. There's no software. There's no. It works on every platform already since it's built in the browser. And the cool thing is, JavaScript is kind of in a unique position that the top tech companies in the world have spent hundreds of millions of dollars making JavaScript faster and better, and on these debugging tools to make your life easier. And you don't even have to do anything to benefit from the work, because your browser already executes JavaScript faster right now than it ever has. So yay, everyone gets to benefit from the expenditures of Google and Apple and Mozilla and Opera and things like that. So there's really no other language where that's necessarily the case. JavaScript doesn't really have an owner. It's kind of, everyone fights over who can run it fastest, which is really awesome for JavaScript developers. So the tools I'm going to show you are available in all modern browsers. I've got some screenshots and examples, and the screenshots and examples are from Chrome, but all of these tools are also available in Firefox and Safari, Microsoft Edge, even Opera. I didn't put Opera on this slide, but it's in there too. And I wanted to give a shout out to the Mozilla team and Firefox Developer Edition. If you guys want to check out some more bleeding edge like dev tools and cooler stuff that's not available in Chrome and things like that, the Developer Edition has some cool stuff and has where you can provide feedback and stuff like that, so that's cool. This talk is in 2 parts. It's kind of slides, which is going to be an overview of what I'm going to show you, and then the second part of this talk is like an interactive. I've actually custom made a whole app for this talk to show you different things in the dev tools, and we're going to go debug this app together. So hopefully it's going to be super helpful, super hands-on for you, so you can really see what it's like getting in the dev tools instead of just static screenshots. But it will have some static screenshots just for the purposes of pointing some stuff out to you. So I think in this list, probably most people have really only had experience a lot with probably the top 2. Pretty much everyone has seen the Chrome console, has seen errors come up, has maybe used it. Console.log is maybe run some basic commands in it, something like that. And then the element inspection, if you right-click on an element and go to inspect, it'll bring up the element inspector, which will show you the DOM as it is currently rendered, which is super useful for especially JavaScript apps, where if you view source, the thing might not be there, but if it's rendered with JavaScript, if the element inspector will always show what's actually on the page and what's changing in it. But then the available tools are actually a lot deeper than that. There's actually interactive debugging with breakpoints on DOM nodes, XHR and fetch events, just regular events, and even code, lines of code and specific statements and things like that. And it goes pretty deep, and we'll get into that. There's a network tab. Probably most people or many people have seen the network tab. If you get like a 404 error, wonder why something's not loading or something, you go over to the network tab and you can see, where that error was. Just out of curiosity, how many people have used the either the console or the element inspector? Just show of hands real quick. Okay, so that's what I thought. Pretty much everyone. How many people have used the network tab? Almost everyone. This is great. This is awesome. How many people have used the have dug into the timeline or performance features or the profiler? Okay, about half. So I'm going to show you a lot of that here. So element inspection. This is, everyone's used this, so I won't go over it too much, but right click, you see the element, all the styles. You can set event listeners and breakpoints. You see the tabs at the top there. It's not showing up on the screen, but it doesn't matter. You can right click and break on subtree modifications and things like that. So this would be like a DOM breakpoint. So anytime this DOM node changes, it'll actually pause execution and jump you in there. Console, I have this slide up here just to show that you can do anything you want with the console. The console lets you interact with any web page you want, regardless of whether or not it's on your domain. So here, I just popped open I went to twitter.com, popped open the console, typed $ to see if jQuery was available. It was, and so I right-clicked on that element in the tweet, got the selector, and then just set the text to that. And unfortunately for me, actually all of these have the same selector, so maybe a bad screenshot there. But something similarly easy, if jQuery is not available, you can actually go edit the body tag and add a content is editable, and just like literally type anything you want on any web page. So I throw this screenshot up just to say, don't believe screenshots. Like if you see a screenshot of something, don't believe it. Get the actual tweet, or get the actual, Facebook post, or get the actual whatever. Get a link to something real, the actual news article. There's a lot of fake stuff going around. So get the source, don't believe the screenshot, don't blindly retweet it as if it's fact, that kind of stuff. So debugging. One of the things about debugging is you can add, does anyone use build tools for their JavaScript to like build and bundle and package all their JavaScript together? Okay, a lot fewer people. So if you do this, there's this feature called source maps, and source maps basically let the browser know what your code actually looks like. So when you compress all your JavaScript together and minify it and obfuscate it and stuff like that, the source maps feature produces a file that actually tells your browser that this line here, or this bit of code from this character to this character, actually maps to this file or this function, and it actually looks like this. And then when you debug, then you're not debugging like minified, obfuscated code. You're actually debugging your real code. I'll show you that. Network. So this is the specific problem I ran into at work. I work on a team that was building a content management system on top of an e-commerce platform. We got a bug ticket that said the site was loading slow in a specific case for a specific customer site that was built. And so I start looking into it, and our code is making two XHR calls. Here's the, or AJAX calls. Here's the first one, and then here's the second one. And you see this gap, this huge gap here. CXM is what our CMS is called, Customer Experience Management. But so this was a ticket that was like, your stuff is slow. And I was like, that's interesting. Why is there a gap there? I don't really think it's us that's slow. Like, it was like, that's interesting. We've tested all our stuff. I don't think our stuff is slow. And so I looked into it and really dug in with the profiler, and that's really where I got all the material for this talk. Just kind of digging in myself to figure out this issue. So there's this huge gap here. This gap is, and by the way, these two AJAX requests go out one after another. It's like bam, bam. But for some reason, one's going out and the other one's delayed. And this one that's delayed is not waiting on the result from the second one. So what could have happened? Well, if you know a little bit about how JavaScript works, basically what happens with async stuff, anytime you're experiencing a lot of slowness with async stuff, or the page isn't updating or something like that, it typically means you're doing too much work in JavaScript. So you're doing what's called, everyone just says you're blocking the event loop. You're blocking the event loop. That's what's going on right here. They're doing a lot of rendering work in the stack that's preventing any more work from the event loop going out. And the whole stack versus event loop thing is a whole nother talk. I don't have a link to it in here, but so I'm digging in, and then so the network tab, and then the timeline performance. So I'm like, okay, well that's what the network tab looks like. How about the timeline? So I load up the timeline for this page, and it looks like this. And this is actually really, really bad. So if I'm gonna help you kind of read the timeline, and I'm gonna go over it briefly here, and then I'll dig into it in the demo more in depth. But basically, what's going on? You see the pie chart at the bottom here. How most of it is yellow. That means most of our time is spent in scripting, in JavaScript, executing some kind of script. And you see these yellow bars here at the top, and then the corresponding red bars on top of there. Those yellow blocks are time spent in scripting. So this is blocking JavaScript right here. So whatever we're doing in here, this is blocking our subsequent AJAX requests that are going out. So we have a huge chunk blocking here. Let's see. We have a huge chunk blocking here, and then we have our other AJAX calls going out here that are just these little bitty ones. And I dug into the problem, and it turns out they were just rendering they were just appending a bunch of DOM nodes or backbone views in a loop synchronously in a way that wasn't good. There's a bunch of other information here, but it's easier to show you the other information in the live demo. So skip that for now. Profiles, I'm just going to show this to say profiles are a snapshot of what's in memory currently. So it's like what objects are loaded in memory, how much memory are they taking up, and then you can inspect them live. So you take a snapshot, and you stop your snapshot, and then you can see live what's in memory, the values of all the objects, everything like that. So if you have a case where memory is increasing and increasing, and then crashing the browser or hanging it or something like that, memory snapshots are super helpful. A blocking example that you saw, this is basically anything that's blocking will look like this. Yellow bar, the red bar means zero, means you're dropping frame rates. So as we all know from playing all those video games, like 60 FPS is kind of what you want, you know, where no noticeable chop or lag or something. Same thing in the browser when you're rendering a web page and updating stuff. If you're doing anything blocking, your frame rates drop, and then everything freezes to the user, and it looks like your page is not responsive. Have you ever like clicked on a button and it like does nothing, and then you click on it like 10 times, and then all of a sudden like 10 modals pop up like 2 seconds later? That's blocking. That's not responsive. This is what's going on that page. So non-blocking, more event-based, looks kind of like this. You're never going to get away from having to update the DOM, so you're always going to have little bits of red frame rate drops where you actually updated DOM. But if you look at the pie chart, the difference here in this script is striking. We see most of our time here spent in scripting, over 2 seconds in scripting, and most of our time here is idle. And look at the chart up there. It's mostly white. That means we're not doing any blocking work, which is great. Memory problems. If you do have a memory problem, there's like three types. There's performance progressively worse over time, which is a memory leak. So you're not cleaning up something. This is typically caused by event listeners being attached to DOM nodes or things like that are not being unbound when the DOM node's removed, because then it can't be garbage collected. There's something attached to it. If there's significant or frequent performance delays, it could be because you're putting a lot of stuff in memory, it's getting garbage collected a lot, especially inside functions or something that can be garbage collected. And if the performance is consistently bad, it's called memory bloat, which it's more of an architecture level problem. So to go over a couple demos here. Yes, okay. Let me increase the size of the console here. Okay, so this is the demo app I made. This is the console. And increase the size of the page too here. There we go. That's better. Okay, so I wanted to show you this. So say you're on your web page. I put a counter at the top, by the way. You see the counter in the title. I put that up there so that when I show you the blocking example, you can see how that number freezes and is unresponsive, things like that. So let's say you're trying to debug some error that's occurring in your app. So I'm just triggering an error. Let's just assume it happens somewhere on our app. And then you get this location where it is. So I'm going to click on that, which goes to the sources tab and opens that file. So unfortunately, I've used a package manager, pretty printed this, or I've not pretty printed this, I've minified this, which kind of obfuscates it. You get this dialog that asks you if you want to pretty print the file. If you click here at the bottom, these brackets in Chrome, and it's similarly placed, I believe, in Firefox and other browsers. But there's always an option to pretty print. You click that, and then you see the actual line where your function was called. If you click a line number, you can actually set a breakpoint. So I'm going to set a breakpoint, and I'm going to refresh this page real fast. It keeps my breakpoint, and then when I hit this, trigger error. Okay, so now I'm paused right here. This paused my execution. You see it says paused in debugger here, and I can see where that error was. So now I can start debugging based on breakpoints on lines. Now this is still obfuscated code, so this is kind of difficult to debug. So if you're debugging someone else's code in production and you don't have the source, you might have to stick with this. But I have the source. We developed this locally, so let's see what source maps can do for us. This line that says debug, here, this line that says debug, it's basically true or false. So if my environment is production, it's going to be false. If my environment is local, it's going to be true. So I'm going to run a watcher that's going to build all my JavaScript into that bundle. And since the watcher is not in production, that was production compiled code that we saw, it's going to generate a source map. And when it does that, actually, I think I might have to build first. I'm going to run build. There we go. All right. I'm going to run build, and then I'm going to run watch, so if we change it more, it'll auto-compile. Okay, so I'm going to take up that breakpoint now because it's going to be a different file. So now let's see what's going to happen. I'm going to clear this. We'll refresh. We get a new. I'm going to trigger this error again. Okay, so now we've added source maps. You see where our error is now? It says home.js line 17. So I'm going to click that, and this is actually the file now. So this is a lot more helpful already. So just with source maps mapping to the original source files, I can still use my compiled bundle, a single JavaScript file to download, but now I can actually debug it with the real stuff. And Chrome also, so I can see where this is now. So I can set that on line 15 of that file, refresh, trigger, and I pause in the same place. So I'm going to go ahead and play through that. You can step through and do all that stuff too. And then Chrome shows me this other banner at the top. It says serving from the file system. You can add your local files to Chrome. So you can actually not only debug inside your browser, you can actually add your local files to the browser to make them aware of them and give them access to them. And then you can actually change the files in the browser and save them back. So I'm going to right click here. And I've increased the font a lot on the UI, but it doesn't seem to be increasing on the menu. So sorry if you can't read that. It says add folder to workspace. So I'm going to click on that, and then I'm going to add my folder. And then it says it's going to confirm that DevTools has full access to these folders. I'm going to allow, and you see it show up here. So now I've got my actual file here. So let's see. It's a component, and it's home. So this is the file that was showing me earlier with the error triggered here. So let's see, console one more time. I'll trigger that error, and now it's taking me to this file. So now when I go in this file, I can actually, I saw that the error was there, and now I can actually remove it. And I can hit save. And you notice the asterisk on that file name, and then I hit Command S, and it saves, it goes away. And since I'm watching the files, since I've got a watcher runner, and the watcher is, it recompiles automatically on file changes. So I've got the watcher running, so I don't have to do the rebuild manually. Now let's play through that. Again, I'm going to refresh that again. I must have another breakpoint somewhere. And then I can, I've got the, yeah, that's where I got the breakpoint. Okay. But you see the error's not there anymore. So I'll hit that. Console. Nothing. So we've actually fixed the problem. So we've debugged it. Real problems are probably going to be more complicated than that. There's a lot of other breakpoints you can set. And I will show you one on inbox. So I'm fetching these messages from a server. It's from the same server I'm running locally here. And we're doing that async, so it's not causing any issues like that. But what if we had a problem on an async call and you didn't know exactly where it was coming from? You can, let's go back to sources. And again, the menus are not responding to the font size increase. Okay, so let's pretend that for a second that I don't know where those are coming from. So if typically this panel is on the side, but the screen's so small it's put them at the bottom. You see these classes of breakpoints. So these are the breakpoints I've set. I'm just going to remove all breakpoints. When you break, you also get a call stack, and I'll show you that in a minute. But I'm going to set you see XHR breakpoints. So I can actually set a breakpoint on any XHR call, and then when I refresh this and fetch, it pauses right there. And you see this fetch up in the source. No, you can't see that on screen. Dang it. Okay, so I'm calling the fetch API here. So it's actually breaking here. Now, if I need to figure out what's going on inside that call, now that I'm in the source, I can actually set another breakpoint wherever I want to. So I'm like, okay, that's fine. I actually need to break down here. So I'll hit play, and then I'll break on my second breakpoint. And you notice in line already, I've got it provides you with the value of the variables in line when you're debugging, when you're paused. If you look at the call stack, you can see, yep, you can see the call stack. It's not big, I guess, and I didn't name the function, so it says anonymous, which is super unhelpful. So I apologize for that. But it does give you the, the place where it was called. Actually, it's paused inside here. If I had shown you the call stack at fetch, you would actually have seen a useful call stack. But another thing is this scope and watch. The scope, these are the local variables defined in this scope. So you see this JSON variable here. You can inspect it by hovering over it and then expanding it. These are the messages that it's giving back to me, and locally here as well. If you want to see how a variable changes over time as you step through code line by line, execution by execution, function call by function call, you can add a watch expression. So I'm going to add a watch expression for JSON.messages. And I can see that that's an array in this context. And then when I play that through, it's not available anymore. So if there's specific things you're looking for, you can look for those, and then if I were to run this again, it wouldn't be available there, but then I could play to the next one, and then there it is. And if you mutate that in a certain way through a series of functions, you can trace that step by step. So really, really cool stuff. Does anyone have any questions so far? If you have a question, you can shoot up your hand and I can answer it. Yeah. Oh, hold on, we got a mic right here. Sorry.
Is this thing on?
Hello. Does the source mapping feature, does that work on if you're developing with languages that translate into JavaScript, or will that just map you to the first translation of the JavaScript?
This code actually is transpiled. So this is all ES6 code. I'm using import statements, which are not supported in the browser. I'm using classes and JSX and stuff. So this is actually all transpiled. So the source map actually points you to the source file, whatever it is. So if you're using TypeScript or something like that and converting it, or closure script or whatever, it can show you the original source files.
Cool.
All right. And throughout this, like I said, if you have questions, just feel free to put your hand up. We do have a mic though for the live stream, so wait till the mic comes to you. Okay, blocking and non-blocking. I wanted to dig into this a little bit more. So notice the counter at the top. Like I said, I put another counter here because that was before I put one at the top. I'm going to click this button and watch that counter. This is what blocking does to your app and why it's so bad. So that counter just stopped, and then it continued. So if your user's on your page and you do something blocking, this is what your user's going to find. So I go to the Performance tab. It was previously called Timeline. Now it's called Performance. I go to the Performance tab. I'll reload. I'll hit block. And then we'll take a look at what that looks like. That's where I got that screenshot. So Chrome has this option. That's not me, is it? Chrome has this option to provide you with screenshots. So if you click screenshots, it actually takes a screenshot of the app as it's going through. And you notice that timer. Notice that that timer is not actually updating at all during this whole block until we finish it. So that's how we know it's blocking. And then up here, did we get that red bar that will show FPS? Let me see frames. Yeah, 0 FPS. Your frames per second. Let's look at the whole thing here. So this is your frames per second, and our frames are like, okay, these are single frames, but we're getting, see, it says 0 FPS for 2 seconds. That's how we know that's terrible. And then we can dig in. So this is a flame graph. Is anyone familiar with flame graphs? They're basically call stacks, okay? So it's whatever you called, and then whatever that called, and that called, and that called, all the way down, and it tapers down until one person familiar with flame graphs. All right, the guy who works on Firefox Dev Tools. Okay, and then you see all these sleep calls down here. So I have do blocking thing, and then all these sleep calls, and then you see all these minor GC garbage collections, things like that. You can also get a other calls, bottom up. Flame graph is kind of like top down, tapers down. You can get a bottom up call stack to see what the actual problem was. It says most of our time spent is in this sleep function. Obviously, that's blocking. It's called sleep, that kind of stuff. So in the real world, what can we do? I wanted to show. I'll run through the inbox. I'll run through events. So what's it? Actually, you know what? Inbox will be a better example because it's actually fetching something. I'm going to hit fetch messages here, and that was pretty fast. And this is kind of the difference between async and sync in JavaScript. So you can see where the messages came through in the screenshots just by me moving here. This little bitty spike right here is where the screenshots came through, and I haven't really dropped any frame rates at all, just by doing that async instead of sync. So if you ever are tempted to do an AJAX call synchronous or something like that, don't do it ever. Don't. It will block. Okay, so let's maybe a more real-world example of something. I didn't mean to have that profile on. Okay, there we go. Let's clear that for now. So this is what I ran into at work. A bunch of DOM nodes were being appended in a loop. And the question is, how can we make this not blocking? How can we still do the work we need to and make this not blocking? So I wanted to include a more real-world example for you guys, so you maybe have something to take away from here and some things to look at. So I'm going to append a bunch of items to this file, and I'm going to do it with several different ways and then show you the difference between those. So I'm going to refresh to get our timeline going, and then I'm going to append them with jQuery, and you see the items were added here after a while. But if you were watching our counter at the top, it's actually still blocking, still not moving. See if I can zoom out here. Come on, it's acting really slow, sorry. Okay, so I have to zoom out a little bit. It didn't even complete. It actually finished the timeline before it completed and appended the items. So at no point do we even see the items come in here. But the point is, you see this big yellow, yellow bar. Most of the time is being spent in building and appending the DOM node. I'll show you how we're doing that here. Okay, so this is what we're doing for this example. Can everyone read this okay? All right. We're just naively building our items in a loop and then appending them to a DOM node. Why would this be slow? Does anybody? Yeah. That's right. That's exactly right. So every time we're calling append here, it's actually updating the DOM. So we're mutating the DOM in a loop, and I think it's like 1,000 times. The items num constant, I think, is 1,000. So we're updating. Well, let's take a look at what that is. Yeah, it's 1,000. So we're actually mutating the DOM 1,000 times in a loop. And we're also using jQuery to parse this HTML and build it, which is, while convenient, is slow. So how can we improve this? Let's take a look at moving this to vanilla JS approach, just plain JavaScript DOM scripting. Vanilla JS is not a framework, okay? And we're going to do something a little bit different here. We're going to create a container node, and then we're going to we're going to create a container node that we're not attaching to the DOM yet. And then we're going to loop, create our items, and then append those in the container node. And then at the end of this, outside the loop, then we're going to append our container node. So seems like it'd be pretty faster, right? We're not mutating the DOM in a loop. So let's check it out. I'm going to hit refresh, and I'm going to click append vanilla. And our items still aren't in. Come on. What's going on here? Okay. And there we go. Whoops. I don't think I clicked it. There we go. So there's our items. We got in our loop, and there's 1,000 of them. I'm going to scroll all the way through them. We still get blocking, though. So this is less blocking. Now we're only blocking for 283 milliseconds instead of like over 2 seconds. So that's already a lot better. That's like almost a 10x speed up. So if you went to your boss and were like, hey, I just improved the code base by 10x, you know, he'd probably be really happy with you, and you could probably go home satisfied, you know, job well done, that kind of stuff. But we're still blocking the UI. We're still dropping frame rates. We can see 4 FPS here. We still get the red bar. So this is kind of potentially still a problem. Not as much of a problem, maybe not as noticeable of a problem. But if this is an operation that you're doing, you know, a lot of times, your visitors are certainly going to notice this. So if you're building a game and constantly adding objects to the DOM, or, you know, something intensive, it's definitely still going to cause some issues. So it might depend on your use case whether or not you want to go further down the rabbit hole, but we are going to, just because it's fun. So how can we do this then? That's synchronous. So what if we just tried to cheat and do this asynchronous? So I've got a append this async. So basically we're going to do the same work as we did before, only this time we're going to use set timeout with a 0 value. If you do set timeout 0, this is going to put it on the event loop instead of the call stack. So we're kind of sidestep. It makes sure we are not blocking the call stack. That's what this does. But it's the same work, okay, as before. So I think this will run faster? Matter at all? We're kind of making our code more obtuse, though, right? We're adding a set timeout. Someone that comes and reads that might not know why we're doing that. So let's check it out. That's the async. I'm going to put my mouse there so I can click on it. And then we got the items back already, so kind of seems like maybe faster. All right, so this is interesting now. We can see where we got our items. The interesting thing here is we've improved our time slightly, but probably within margin of error, right? But look at the call stack. Look at the flame graph here. And look at the blocking. So our red bar here, we're actually only blocking for about half of that time now, instead of the whole time. And what's interesting is we've done all of our, whoops, sorry. Let me just reselect that. Okay, so we've done all of our work here, and you see the set timeout calls here that are called 1,000 times, you know, at the bottom of this call graph, and then that's where the blocking bar kind of stops right there, and then you see all this actual work here where the DOM nodes are getting inserted. So we've done a little better. We're not blocking anymore. We're only blocking for about half the time. It's taking roughly the same time overall, but we're only blocking about half the time. So we've actually made the page a little more responsive, done a little bit better. So that's interesting. We're basically, so what have we done here? We've basically said, instead of forcing you to render right now, you can render, I'm going to tell you to render at the next tick of the event loop in JavaScript. So we're putting it all on the event loop, which does help. But what if instead of us telling the browser when to render our stuff, what if we could actually ask the browser when it's ready to render and then give it stuff to render? So that is what request animation frame is. So we're going to go over request animation frame now. So we've replaced our set timeouts with request animation frame here. Let's get that highlighted. It's difficult to do that quickly with single free hand, but we're using request animation frame instead, and we're providing our function, and we're passing in our function, and basically and then our function is going to call request animation frame again if we still have items. So this line here, if we have items left, if we haven't printed them all yet, we're going to request another animation frame and do another batch. So we're batching this now into a certain number of times here. So let's do this first. Okay, so we're batching. We're going to start at 0, and we're going to do 100 at a time. We're going to do 100 DOM nodes at a time, and we're going to see what happens. And we're just going to append those. All right. So I'm going to refresh since I changed the JavaScript there. Okay. Okay. So I'm going to hit request animation frame, and we see that our items are appending. They're actually still appending now. So we actually haven't done this faster. But look at our timeline. We're not blocking. We're getting 23, 29, 30 FPS consistently, right? So maybe did it a little bit too fast, but we're not blocking at all now. So the timer will continue to run. You saw at the top of the page. I'll do it one more time. Top of the page, request animation frame. That timer up there is continuing to run. It's a little bit jittery because we're getting about 30 FPS now instead of our 60. So what you essentially have to do, request animation frame is like the browser saying it's done all its cleanup for the next cycle and says, okay, I'm ready to paint stuff, and then you give it stuff to paint. So maybe we gave it too much. But you can adjust this number, dial it in for whatever device you want to use. So we'll go here. So this is actually faster. Less, so that's interesting, right? So the thing about request animation frame is the answer to how much work you do in it is, well, it depends. So we actually went from 100 DOM nodes down to 50, and it actually did our work faster overall, which is kind of weird. But the thing is, we were doing too much work, so we were actually running up against blocking the browser a little bit, and that'll depend on your device. How much memory RAM you have, anything like that. Let's see. No, that was it. Okay, and then if you do them all, whoops, I had difficult to do this one-handed. We're gonna do them all in one go and see what happens here. And we'll click the okay, so we actually blocked again. So even using request animation frame, there's the animation frame fired thing. We just did too much work in it in a single frame. You want to complete your rendering in about 10 milliseconds or so with request animation frame. This will depend on CPU speed of your device. On a mobile device, it'll be different, and you kind of have to dial it in. So the goal of all this, though, is to say we can do this non-blocking. It does take a little bit of work. But our fastest time through with no blocking was when we did 50 here, and then we're done already, see? So all this is to say, this actually took a longer amount of time. Well, I highlighted the wrong part of the frame here. It's over here. where all the animation, well, no, it is here. So it's doing all the work here, and overall it's taking us, about a second or so to get all those items in. But since it's not blocking, so although the time, and before when we were blocking, we did it in about 200 milliseconds-ish, and we were blocking for about half of that, so like 150 milliseconds or so we were blocking, and we got all the items in faster speed-wise, but we were still blocking. So in JavaScript, really all programming is kind of trade-offs, and in JavaScript, I think, especially on the front end, is about trade-offs. So you might choose a trade for a longer overall time for a faster perceived speed to the user. So since we're not blocking at all, this is going to seem faster for the user. And since the user can't scroll down and see the 1,000 nodes anyway in a second, it's really not going to matter. So it's a trade-off. We're taking over a second to do it now, but it's not going to make any of the rest of the app unresponsive at all. So it's a trade-off, right? Are there any questions about anything I've done here? Okay, we have one in the back there. Green wall.
The profile timer to start and stop when you click the button.
Oh, sure. Yeah, when you first, so I'll clear this.
Because I tried to do the profiler, but it always starts at the beginning, and I can never drill down into the one part I want to look at.
Yeah, so you can actually start in time and stop at any time if you manually click the record button or hit Command E. I just hit Command R to reload the whole page and then clicked, and Command R reloads and evaluates the whole page. So and it tells you right here if you load it up empty. If you start in the performance tab, if you're already there, when you refresh, it'll start tracking immediately. Otherwise, you can. And you're always going to have this initial stuff that has to download and parse your JavaScript. So you're never going to get away from that. But if I wanted to clear this and then, again, difficult to do this with one hand. If I want to click Command E and then click a button, I can. So there we go. So I can start and stop it with just a command. Yep. Okay. And then turns out that's really about the fastest we can go. So instead of saying to the browser, hey, render this stuff right now, we're asking the browser for the next animation frame. That's the request animation frame. So so instead of ordering the browser around, we're being nice and we're saying, can you please tell me the next time you can render stuff, and then I'll give you some stuff to render. And it's this cycle. So are there any further questions? Anything performance or anything in there you want to see? I didn't show the memory. I'll show you one more cool thing before we go. We're almost done here. Allocation profile. So if you're doing an allocation profile, I'll do this, and then I'll hit start, and then I'll append jQuery, and then that's done. So I hit stop. Okay, so I did an allocation profile, and what this shows is all of the functions that are, this is actually from a plugin, but it shows you functions that have used the most memory, and you can sort by that. You can drill into them, all kinds of stuff, useful stuff. You can just go deep, 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 deep. Anyway, there's a bunch of stuff in there, but just all the debugging tools you need are here in your browser for free by all the major vendors. So dig in your code, start profiling it, and see what you find. Thanks.
All right, we're going to have another 10-minute break.